All right, so we're talking about what does not describe the angle below. And what they're talking about is the notation with your letters H, I, and G. G being your vertex, GH being your rays, and GI. Now, let's talk about what is, right? What is some ways to describe this? And it would be H, GI, I, GH, and then angle G. So here, and if there was a number here, I could say maybe angle 1 as well. These are some ways in which you could. Some ways which you could not. Basically, what you're looking for are any options where H, in this case, or G is not the vertex. So since G is that vertex letter, that is mandatory, it goes in the middle. So, anytime H-I-G, maybe they put I in the middle, H-I-G. These would be some examples of what is not, because your middle letter is not G, which is needed being that is the vertex. It's not too advanced, but something definitely worth looking at. And don't forget, I'll put these up on the board later on. Now, we went over this a little bit in warm-up, talking about interior points such as P and O, and then exterior points such as N and Q, and then you may even see on the angle points, which would be K and M, and I believe you won't see it as much, but they could put L on there for you. This is based on the idea that your angle has created this infinite space between points K and M, this space in between here, and anything in that space would be considered your interior, and anything outside that space would be considered your exterior. I like this question because it's kind of getting you to look at this arc here for the first time. And this arc is directing you to look at this angle made up of these sides. And because this angle has more than one point on its sides, so for instance, this one side is made up of points C and D, and then here you have points I and G. Key piece always being that B is the vertex. So you could have any amount of names, D, DBI, CBI. I'm using these points on this side here with B as my middle letter vertex connected with the I. And then the other way around, you could just say IBC, IBD, you could say IB, or I'm sorry, you would be able to say GBC, anything like that. Now, if you see an answer like ABC, right? Let's look at ABC in green here, right? Let's say we're looking at ABC. ABC is talking about this angle here because we're using A as a side, B as a vertex, C as a side. So really they're talking about this straight angle here. So that's not something that you could use as a proper name for this. You would not be able to use A in any of your angle notation because A is not on this side of this red angle that we were talking about. So keep an eye out for vertex letters and maybe a letter that's not included on the angle that they give you based on the arc. Now, we talked a little bit about angles and what makes up an angle. Case in point, two rays that meet at a common vertex. So it's good to take another look at that. But what you want to look at, something that we talked about when we were dealing with planes, lines, and line segments, etc., is this three non-collinear points. And basically this idea that these non-collinear points could make up an angle. Now, they don't just make up one angle, they may make up a few angles, like this angle here. And we like to use arcs a lot when talking about, where our space is. And this was a red. So you have an angle here, and then you also have an angle which uses this as its vertex here. So 3 non-collinear points, which we have here, we'll call them non-cos, right? Make up at least one angle, and could make up at least one up to 3, I would say. So this is just something to look at, and this is a diagram that we'll be using a lot because it talks about adjacent angles and congruent angles. When you guys are working with angles, what you'll see a lot of this is the measure of ABC is 50, and the measure of RST is 50. So are they congruent? And yes, if 2 angles have the same measure, 2 angles, ABC, have the same measure of 50 degrees, even if they look different or they face a different way, so in this case, this is facing a different way, we would consider them congruent. And this word here is talking about the measure. How many degrees? And in this case, this is the same size and shape, and they go on infinitely. So just an idea of what is this symbol here? The measure of angle. Measure of angle. We would say that that's what this means here, in degrees. Just a little bonus note here, which we'll see a lot more maybe as we go on talking about triangles and angles and whatnot, is this idea of supplementary and complementary. Supplementary, if I take a straight line and I put a point somewhere on that line, I've basically, and I've created a straight angle here. Now, a straight angle is made up of 2 opposite rays. What does that mean? That means these rays are going opposite directions. CB, ray CB, is going in the opposite direction of CA. Notice I put the arrow over B and A. And that makes up a straight angle here. I've butchered that word. Straight angle here. Now this straight angle is basically half of a circle, right? If I take a circle, I cut it in half. Circle's 360 degrees, so this angle here is going to be 180 degrees. And two angles that add up to 180, maybe this is 130 and 50, would be known as supplementary. Now let's say, and they don't have to be adjacent. What does that mean, adjacent? Well, let me draw 2 angles here with, let's say, BD as a side. Here I have AB, ABD, and DBC, right? So here's 2 angles, and they share a common side here, right? So let's say I have 2 adjacent angles. So this is an example of adjacent angles, so I'm kind of pointing that out too. So maybe we want to add this here, adjacent. Because they share a common side, right? It's like if 2 people live next to each other in an apartment complex and they shared a wall, you would say they're in adjacent apartments. They share a wall. So these 2 angles, 1 and 2, are sharing a common side, therefore they're adjacent, and common vertex. So common side and vertex. Now, these 2 angles that are adjacent, that share a common side and a common vertex, also add up to 90 degrees. Maybe it's 40 degrees and 50 degrees. two angles, they don't have to be adjacent, although these are, that add up to 90 degrees, we call this complementary, right? This is what this is. So notice complementary deals with 90 degrees and supplementary deals with 180. One way I kind of remember that is if you take the first two letters, of supplementary and the first two letters of complementary, I could make a 180 out of supplementary, and I could make a 90 out of complementary. This is kind of my way of remembering 180 for supplementary and 90 for complementary. And that there's just a little side note.